For our project, we had the following goals for each component of our project. The lead rover would move around the map and pick up tokens based on information from the coordinator. The follow rover would just go around following the path of the lead rover, and when it notified a token, it would go to that destination and pick it up. The coordinator would create a map of the area and send movements to the lead rover so it can maneuver. The sensor detected obstacles and reports the position and orientation of the lead rover and follow rover. And then for our monitor, we use a Raspberry Pi to display.
So for the camera that we use for the sensor is the Pixie Cam CMU Cam 5. The main perks of this camera that we liked was its ability to assign multiple color codes to different objects, which allow the camera to quickly identify all these objects and report the data. In particular, once the camera detects an object, it can send a byte of data to the PIC32. The types of data that I personally used from the camera was the sync byte, the checksum, the signature number, the X and Y position of the object in pixels, and the orientation in degrees. The only flaw that I found in this camera was that the lens that it came with was distorted. In particular, it had a 75 degree view of angle, which caused a fisheye distortion in the camera. So in order to fix this, I had to create a distortion correction algorithm or method. The way I did it was I took multiple samples of the data and manually recorded all the positions of the object with respect to the camera. Once I recorded enough samples or had a correlation in the data, I created an algorithm in order to shift the objects to their correct values.
Okay, so for my part, I did the follow rover design. So the follow rover is composed of three main tasks: the data task from the Pixie camera, the message data task, and the main task. The Pixie and message data task both use a generic data format, which we put on the queue and use in the main task. The messaging task took messages from the Wi-Fi and put them on a queue, and the only messages I would receive were from the lead rover and to notify that the token was found, and the only messages that were sent out from the follow rover were token pickup messages. In the Pixie data task, this took data from the Pixie camera through UART as well, and then the data would be processed, and the ones that I used from the messaging from the Pixie data were the signature number, the height, and the X coordinate objects from the object detected from the camera. The signature number was used in order to identify which objects were detected. The X coordinates were used to determine the position from the follow rover to the lead rover, and the height was used to determine distance between the follow and lead rover. In the main task, all the data interpretation was done from the messaging queue. So the follow rover had a specific algorithm that was executed, which was to first find the rover. Next, it would go to the lead rover. Third, it would observe the lead rover and until the lead rover stops moving. And in this time, it would capture its current distance and the distance at which any tokens were found. Next, it would catch up to the lead rover and pick up any tokens on the way based on the distance that everybody knows. Then it would wait for the lead rover to turn, and once it detected it turned, then the follow rover would execute a turn procedure, and then from there it would just repeat that same steps over and over again. So then it would find it, go to it, observe it, and then wait for it to turn.
I was in charge of our group's coordinator. Essentially what that meant was that I was responsible for the algorithms that interpreted the sensor data, as well as generated movement commands for the lead rover. Now, due to the nature of the lead rover, only being able to see tokens that it was directly over top of, it was necessary that I had the lead rover go over as much area of the board as possible in order to find tokens. To accomplish this task, I had the lead rover move in a predetermined Zamboni type pattern, essentially a rectangle that translated across the grid. When obstacles arose in front of the lead rover, I would divert the lead rover around the obstacles and get it back on course of that pattern. Now this proved to be a very robust solution and allowed the lead rover to move around the board very easily and cover as much territory as possible, minimizing the amount of doubling back on itself and whatnot. However, there was one failure in that, due to the nature of the way that our follower rover worked, our lead rover could not enter enclosed spaces where there would be obstacles on 3 of the 4 sides of the rover. It could handle 2 sides, but not 3. Other than cases like that, it proved to be a pretty robust solution. Now, unfortunately, the coordinator was not ready in time, and so it was not included in integration and was not demonstrated in the final demonstration. However, to test the coordinator and to show its working, I took our group's message router Python script that we were running on the Raspberry Pi, and I modified it to be able to spoof messages by creating modules that I added to the router code, pretending to be the sensors and the lead and follower rovers. This allowed me to send messages and commands and data to the coordinator and then take those back and interpret those to make sure that the coordinator was sending appropriate commands. This proved to be immensely helpful and really helped speed along the process of determining that the coordinator was working as it should have been.
Alright, the part that I did was the lead rover. The lead rover is responsible for receiving commands from the coordinator and following those commands to search for tokens on the game board. The method I used to find and identify tokens was to use a line following IR sensor. What this was is basically a line sensor. It consists of 8 IR sensors that basically send out an IR pulse and then see how long it takes for it to reflect back to them. As it takes a longer time, that means there's a lower reflectance. So when we have a white board underneath and then black tokens that we use, which have a much lower reflectance than the white background, it's easy to see the difference between the white and the black. And so when the lead rover drives over a token, the sensors will detect that, and as long as at least 2 of the sensors detect it, then we can decide that we have indeed found a token. In order to follow commands from the coordinator, basically we have a system that just monitors the speeds of the wheels, detects how far each one has gone, and adjusts them to compensate. In order to do this, we read the encoder data from the wheels, which will feed into the a counter, basically a timer counter, and whenever that counter reaches a certain value, it triggers an interrupt. And that interrupt will keep track of the number of ticks that each wheel has hit. So we can see how far each wheel has gone, and then a separate task will adjust the speed of one of the wheels in order to compensate if one of them gets ahead of the other. This also allows us to keep track of the distance that we've traveled. So when the coordinator would send move forward 10 centimeters, we can do a conversion on that 10 centimeters to determine the number of ticks it would be and determine how far we need to travel. And then once we've reached that number of ticks, we know we've traveled that distance and we can stop. Once any move is completed, we also send a move completed message back to the coordinator in order so that it can know when we're ready to do a new movement.
terms of robustness for both the sensor and the follower, one of the main issues was that the Pixie Cam would sometimes pick up feedback in the background, which caused both of our cameras to read false values. This was a greater problem in the follower, but he was able to solve this by putting up walls around the obstacle course. Also, one of the issues with the robustness of the camera is that some of this camera is really particular to the lighting of the environment. Too much lighting would cause the camera to not read anything. Likewise, too dark would cause it not to read anything as well. The other problem is sometimes the environment is also not correct. The hues of the images will also start blending, so sometimes we will start reading two different similar hue colors as the same object. And the reliability of the sensor was sometimes not always best. For my part, was sometimes the sensor would not always start when I wanted it to. Likewise, it would run a long time. However, if one object was obstructed from the sensor, it would cause the whole entire system to crash.
The reliability of the lead rover was very good. There weren't really any issues with the lead rover failing to do something partway through. It would always start up and take commands how it was supposed to and find tokens properly. One issue that it could have is if there was extremely different lighting, or if the different materials were used for the background of the tokens, it could cause the sensors on the lead rover not to detect the token properly. But within normal changes of ambient light, it would work very well. In terms of our messaging system that we used, we didn't have any failures in communicating messages to each other. When we sent a message, generally the recipient would receive the message and it would receive the whole message and understand what it said. There wouldn't be any lost packets or anything like that. We had a good, reliable system that way.
In terms of design, both of the sensor and the follower both use the Pixie Cam. In the end of our design, we concluded that Pixie Cam was probably not the best option due to the numerous problems that it had. This caused a lack of reliability and robustness in both our components. In terms of the sensor, the faults of the camera caused issues with obtaining reliable position data due to the distortion of the lens. And for the following rover, the camera would sometimes send certain signature values in the background, which would throw off the follow rover and cause it to be off sync with the lead rover.
In terms of failure with the coordinator, since we had to manually maneuver the lead rover, it was hard to get the timing down of the movements for the lead rover or for the follow rover to correctly follow the path of the lead rover. In terms of the lead rover, there were very little failures, or if none, there was none at all actually. Everything worked as designed. For additional design requirements, we did pretty good on keeping in budget for our project, but I guess in the end we had a lot of money left over, so we could have spent more time looking at different components and maybe getting higher quality cameras, or even purchasing special lenses for our sensors.